Hello everyone, happy Android Summit 2020 and happy second day of conference. We're gonna talk about testing in Flutter and how easy it is actually to run tests. But first of all, I wanna apologize because if you're watching this video, that means that we're not doing this live. Unfortunately, I had an unexpected event, so that prevents me from being live, and this is Plan B. But I promise you that it will be as smooth as Plan A. That's it. Let's jump into it. Let's talk about testing in Flutter. So, what we're gonna do is that we already have this beautiful application that runs on macOS that is just a simple quiz. It asks you a few questions about like things about the event or Android, and once you complete the quiz, it gives you the result. It gives you the score. So, what we're gonna do is to learn about how to test this application with the Flutter test framework. What are the types of tests that we can do out of the box with the Flutter framework? Of course, unit tests, and especially this works really nice when we have pure Dart classes that don't have any Dart dependencies. Think about JUnit for Java or for Android in this case. We also can run widget tests for isolated widgets for isolated pieces of your user interface. And this is similar to what you could achieve with Roboelectric, right? And finally, we have integration tests that will test your application running on a real device, on a simulator, and this is kind of like your espresso trace for Android as well. So what do we need to create tests on Flutter? Well, what we need to do is to make sure that we include in our path spec the Flutter driver for the integration test, Flutter test for widget test, and finally the test library, and if needed, Mockito. Why not? We'll talk about that later. But pretty much, let's see the code first. Let's see what do we have in our application and what's gonna be our approach. So the main entry point is very, very simple. We're gonna run the Android Summit 2020 app, and we're gonna inject a guess game. Our guess game is very simple. It has two public API methods. One that loads a question given an index, and the second one, it checks the score given the index of the question and the answer provided. And just to make it a little bit more fun, we're returning a feature of type score instead of just like a synchronous score method. So we can demonstrate how to test asynchronous methods as well. Then we have our Android Summit like UI, right? So in this case, we're gonna have a material application and immediately we run the questionnaire. And the questionnaire is gonna take the game object, right? And it's gonna be a stateful widget. And pretty much what we're gonna do in here is like to check our state and see if we have a question to load or the final score to render. And then there's a check answer method every time we click on a button to determine what's the state of our application. These internal details for the widgets, actually they're not gonna matter that much, but still it's nice to understand how the code works, right? So with this done, we see in here that we have two different widgets, question and final score. All right. But something that someone probably did notice already is that there's no test. There's no test folder actually. So let's start writing some unit tests. And the first thing that we need to do is to create our test folder, as we can see on the left on the file explorer. And we're gonna create a new class called guessGameTest.dart. All test files must be suffixed with _test in order for the test framework to pick them up. So now let's start writing our test. The first thing that we need is a main method. And inside the main method, we're gonna create a test method with a description about the test that we want to run. As we can see, the test method is not imported. We need to import the Flutter test package in order to have access to the test method. And we can start writing our test. So what do we wanna test first? Well, we wanna test the load question. And if you remember, given an index, it would give us back the question. So what we can test is like create a guess game, and for each one of the questions that we have, expect that they're in the index that we want them to be. If we run these tests, they pass without a problem. And because they're unit tests, they're quite fast actually. They're running under a second. We could have actually like a few more tests and they would still run under a second. So let's recap for a second what we've seen, because it's quite a lot of information if you've never done tests on Flutter. The first thing is that every single test file must have a main method. That's the entry point for our tests. Then we're going to use the test keyword for each individual unit test. We're going to use the Flutter test as our testing library. We could use also the test library, but the Flutter test is a little bit more nice. And we use the expect method to run assertions. If we want to compare the result against our expectation, that's what we use, expect. And finally, on the CLI, we can run Flutter test to run our test. There's something that we can test also in here. We had 3 questions. So what if we try to access the question on the index number 3? That's going to throw an exception, right? Well, we can test that as well. As you can see, we create a second test method. We still create a guess game object. And for the guess game load question on the index 3, we can assert that it throws a range error. That throws range error is a custom built-in matcher from the Flutter test framework. If we run this test again, as we can see at the bottom, it passes without a problem. However, can we refactor our tests a little bit? And the answer is yes. And it's a good practice actually to refactor your tests as you go, because our tests are incredibly important, and the easier they are to understand, the much better they're going to be to maintain, right? So what can we do in this case? Well, we see that we're creating the guess game in both tests. So we're going to try to see if we can reuse this object. The test framework offers a few things. It offers lifecycle hooks. That means that, for example, if we create a hook called setup all, we're going to access to that code just once before runs any test. We can use also setup, and this hook will be executed once before every single test. So if we have 3 tests, it will be executed 3 times. The mirror method of setup is teardown. It's going to be executed once after every single test. So if we have 3 tests, it's going to be executed 3 times after each one of these tests. And finally, we have a teardown all, that it will be only executed once, regardless of the amount of tests that we have at the end. It's going to be the last step. So with that information, we can create a setup method, and we can initiate our guess game object inside the setup method. So we can reuse it in every single test, and we don't have to instantiate it every single time. Let's continue testing the public API. With this, we've tested already pretty much the entire load question method. But now we have to test the check score. And this one, you might think that it could be a little bit more tricky because it is a feature, right? It's an asynchronous method. Well, in reality, it's kind of simple to test. Let's take a look to this. We can get the score for like the first, the second, and the third question and assert our results. And we can do that for all the questions that are right and all the questions that are wrong. And as you can see, it's not that hard. There's no like changing threads or anything like that. What's the only thing that is different? Did you notice something that it's kind of cool actually if you use Dart and Flutter? Look at it again. Do you see it? Yeah, we just tested asynchronous code, but there's no threads or anything, right? Async and await in this case are the best keywords that we can use for this. We're going to annotate our methods with async, indicated that, hey, there's going to be some asynchronous code inside this callback. And for every single method or property that returns a feature, we can just wait for the result. So very handy, very simple. There's not that much difference. And with this, now we fully unit tested the public API of our guess game method. However, let's keep asking ourselves, can we refactor this test a little bit more? What do you think? Yeah, the answer is gonna be yes. These tests are starting to be a little bit disorganized. We have the load question, a second method for the load question, then a test for the check score, right? And there's no order or grouping or anything. So in Flutter tests, we can utilize the group method to group our tests by whatever category we want. In this case, because we're dealing with unit tests, we're gonna group them by public API. So we're gonna create a group for the load question method, and all the tests that we execute against this method, they're gonna be inside this group. And same thing for the check score. And as we can see on the left, it actually reads really nice, and like the IDE applies some formatting when it comes to grouping that makes our test much easier to read. If you don't see the benefits of doing this at this stage, well, it's because we have 4 tests. But imagine having hundreds of tests within the same file. It gets pretty big, right? So having this type of organization helps quite a lot. All right, so with this, we have completed the unit test for the guess game class, and I guess the talk is over, right? Not really. Let's see what we've learned so far. So we've learned how to create unit tests using the test method. We're also using the expect keyword to make assertions, right? We know that there's lifecycle methods within the test framework: setup all, setup, tear down, and tear down all. And if we want to test asynchronous code, we just need to use the async and the wait keywords. That's it. It's as simple as that. And if we use the group method, we can organize a little bit better our tests so they're easier to maintain. Because in Flutter we have widget tests, let's keep adding more tests, right? Like if we only unit test our model or our like brains, in this case the game of the application, we're leaving actually quite a big part of the application untested, that is the user interface. So let's see how we can test that. And first of all, is like, what are our widgets? What are their mission? Like, how many widgets do we have? How do we test this? Well, the Android Summit app has, in this case, the real app widget that takes a guess game as a dependency in the constructor, as we saw, but we don't do anything with it. We're just passing it to a lower widget in our widget tree. So in this case, because we don't have any behavior in this widget, we're not gonna mock it. We'll get to that in a second. It simply creates a material app, right? And we can just assert that we can find this widget. And then we can assert that it renders the questionnaire that we wanted to find. And we can find this widget. Let's see how we do that, right? As we can see, just as an example, we inject the guess game in the constructor, and in the build method, we just return a material app that has inside a scaffold, an app bar, and then a questionnaire. So we could find all these widgets for our test, and if we can find them, then that would be a successful test. For the questionnaire object, it takes the guess game as a dependency in the constructor, but we're gonna use actually the guess game to determine the state of the questionnaire, right? Like we could be loading like the first question or the second or the third one, and based on which one we're loading, we're gonna show something different on the screen, or we're gonna show the final score. In this case, because that guess game dependency has behavior, what we're gonna do is to mock it. We're gonna control its behavior. We're not gonna let the implementation details of the guess game be in our test for the questionnaire. Why do we do this? Imagine that instead of 3 questions, we had 1,000 questions. It would be a pain in the ass to go through like each one of those 1,000 questions. However, if we mock it, we could determine how many questions do we have, which one do we want it to be right, which one we want them to be wrong, or which one throws an exception. And then we can test our widget against those different states. So let's take a look to this, right? As you can see, the questionnaire is a stateful widget. It has some internal properties, but pretty much we're gonna determine like if the game is finished or not. We're gonna show either the question or the final score. All this is gonna be available on GitHub. It's not important as of now. We're just gonna focus on writing the test for this. So where do we start for widget tests? Are they any different than unit tests? And the answer is really no. We're just gonna create a new test file inside our test folder. In this case, the app_test, right? And it starts with a main method. But after that, we have a few different things. We're still gonna import the Flutter test package. However, this time, instead of using the test method, we're gonna use the test widgets method. This is gonna allow us to inflate our UI in a non-UI environment and do like things like tapping buttons or find widgets and things like that. And in order to do that, the test widgets method gives us access to an instance called widget tester. And with this tester, we're gonna be able to pretty much like play with our application. We're gonna see how that happens. Again, to recap, we use test widgets. We use the widget tester to interact with the user interface. And we use finders. There's gonna be an object called find that is gonna allow us to find certain things on the screen based on text, based on type, based on like a key that we could give to our objects, right? And then there are special matchers, right? We saw before that we had a matcher to assert that a certain index was out of range. for test, like for widget tests, we have different matchers that they're going to allow us to find or not find certain things on the screen. So finds one widget, finds and widgets, finds nothing. Let's see how we use that. Again, we're going to create an instance of the guest game. We decided that we're not going to mock it for the Android Summit 2020 app widget, right? And we're going to pump our widget. Pump widget means kind of like inflate this UI. We're going to inflate the Android Summit 2020 app, and we're going to expect two things. One, that we can find the material app widget, and second of all, that we can find that questionnaire widget that we had on the screen before. And that's pretty much all the tests that we need for this widget. We could try to find the scaffold and the app bar, but I decided in my case that it wasn't necessary. Let's continue with the questionnaire, because I think this one is where like you can see that there's more difficulty, and it's also more fun to test. It starts the same way. We're gonna create a questionnaire underscore test.dar, right? And our first test widget test is gonna be that we can render the question and the final score when the game is completed. So how do we do that? Well, in this case, we're gonna start with Mockito. We said that we wanna control the behavior of our guest game dependency. So how do we use Mockito? Well, the syntax is something like this. We're gonna say that when our object receives a certain method, a certain property, or a certain call, then we're gonna return a fixed value to control the synchronous behavior. However, if we wanted to control asynchronous behavior, it's gonna look a little bit different. Instead of using when, then return, we're gonna still use when, but then we're gonna answer, and we're gonna have the option in there to provide a synchronous call, like a future or a string, whatever we want it. Very similar, but synchronous uses then return, asynchronous uses then answer. So, okay, let's write that. We're gonna create in our setup method the guest game instance, but as we can see, we're not creating a guest game per se, we're creating a mock guest game. Where's that class coming from? Well, if we see between the main method and our imports, we see that we created a mock guest game class that extends mock coming from Mockito and implements the API of the guest game. So with that, now we're gonna be able to use the again, then return, or like when, then answer to control the behavior. So if we keep looking at the setup method, we see that we're saying, hey, for the guest game load question on indexes 0 and 1, we're gonna return a fake question that we just call test question 1 and test question 2. However, for the check score methods, we're gonna use the then answer because remember, it returned a future of type score, right? And as we can see, it's very similar. We're just returning an score. And as we can see in here, what we're doing is reducing the amount of questions that we have, because what was in between the first question and the final score didn't matter in this case. We can just jump into the final answer, right? If we look at the bottom, we still have to write our test, but what we've done in the setup method is to create all the dependencies and put them in such a state that we're gonna be able to test this widget. So why are we mocking? Again, it's because we only care about the public API contract between dependencies, not about the implementation details. We talk about this. If we had 100 questions, it would be really tedious to test. And we can force what state do we want to have for our dependencies and throw successes or error as desired. So let's complete the test. Let's remember our UI. We had the questions and the yes and no button. So if you tap on yes, it shows you something. If you keep tapping on yes, it shows you something. If you tap on no, at the end, at some point when the game is over, you're gonna see the final score. So how do we test this? Still, we're gonna pump our widget. In this case, the widget that we wanna pump is the questionnaire, and we're gonna pass the guest game. But remember, that guest game is a mock. Then we're gonna go and try to find the text question 1, right? And we use expect for that. And we try to say that there's only one widget, it finds one widget. Then we're gonna tap on the yes button. We're gonna find the text and we're gonna tap it. And then we're gonna expect that we have the test question 2. Finally, if we tap again on the yes button, we should be able to see the final score result, right? It looks like this test should pass, but it didn't pass. Let's take a look to our error message. It says that the questionnaire renders the question and the final score when the game is completed, and there was an exception. It says that, hey, for the widget text, there was an assertion thrown, and if we keep reading at some point, it says, the specific widget that could not find a directionality ancestor was rich text. That means that the text method needs some setup to do before. So the easiest way to do this is to try to add, even if it's a simple widget, we need to add some scaffold, right? This is why the material app is nice, right? The material app is going to set up a bunch of things for us, like the navigator, some localization delegates, directionality, and all the stuff, right? So what we can do to keep testing our UI is just to wrap it in a material app widget, and it's going to do that setup for us. However, in this case, it's not going to put an scaffold or an app bar. And that's okay. We don't care about that because we didn't need it for the questionnaire object. So now we should be able to run this test again and see what happens. But as we can see in the error message at the bottom, it keeps failing. And actually the error message in this case is kind of weird. It says that we cannot find the test question 2. Let's read our test again. We find the first test question. We tap on the yes button, so we should be able to find the second test question, right? Well, not really. Let's see what's going on. Between question and question, there's an state change, right? So what we have to do is to tell the system like, hey, there's like a new frame, there's a new animation, pretty much like your UI changed. So can you please repaint our UI again? When we need to repaint the UI again, there's two options, pump and settle. Pump pretty much is just gonna move one frame. And pump and settle, what it's gonna do is like, it's gonna check the framework to see if there are any animations going, and it's gonna wait for those animations to complete. So in this case, if we use pump and settle, we should be able to fix our test. Let's take a look. Let's see what we've done. We have still like the expect that we can find the test question 1, and then we tap the button. And immediately after we tap the button, we do like, hey tester, please pump and settle, right? That's gonna complete the animation, and now we're gonna be able to see the second question. And after we do the same on the second question, we run again test pump and settle, just so we can assert again that the final score is present. So at this point, as we can see on the left, all of our tests are passing, and now we can celebrate. Because hey, we've actually unit and widget tested our entire application, our entire game, right? But are we sure that we have tested something, like everything? Are we missing something? Well, we can actually run our test with coverage enabled. If we run this command on the CLI, we're gonna get a file in a new folder called coverage, and this file is called lcov.info. And I don't know about you, but when I see this content, I don't understand what's going on. We need to have a visualizer for this type of format, right? Because that is not like human readable, that it's like, at least I don't understand it. So we're gonna use this call, like this tool called lcov, to generate an HTML report out of the lcov information that was generated before. So with this tool, if we like, there's a special CLI command called gen.html, and it's gonna give us a report like this. And as we can see, for example, all the red lines mean that we have not executed that line of code during our test. So my question to you right now is like, do you think you can fix those tests? Do you think that you can add the coverage necessary for those lines to be executed? If so, this project is open on GitHub. Feel free to open a pull request and I'll be happy to review it and merge it. It's a challenge that I have for you. But hey, for like doing this in like kind of like 20 minutes, it's not bad actually. We've almost covered 100% of our code. So far we have unit tests, we have widget tests, but oh man, we haven't run integration tests. And you might be thinking that actual integration tests, they're challenging. If you've done espresso tests before, they're not that easy to write, but actually in Flutter with Flutter driver, they're quite easy. Let's see at what do we need to run this integration test. First of all, we're going to create a new folder and we're going to call it test driver. You could call it whatever you want, but in the Flutter tutorials that you're going to see online, this is the standard name. We're going to create two files. The first one is going to call app.dart, that it's going to contain an instrumented version of our application. This is going to be pretty much like pointing to where the application is, to our existing main method, sorry. However, we're going to enable a little bit of magic for the Flutter driver so we can actually run our scripted test over the simulator. The second file that we're going to create, we're going to call it app_test.dart, and it's going to contain the scripted test. It's going to contain the necessary Flutter driver to interact with this type of application so we can like assert on a real simulator that a UI works and behaves as expected. However, that said, integration tests, they're considered blind tests. We don't have access to the internals of our project. We're not gonna know, or like we're not gonna be able to access any widgets by its type, for example, or anything like that. So we're gonna have to find either text on the screen or find widgets by key and things like that. All right, so let's start working on this. As we can see, there's a test driver folder, a new one created on our file explorer, and it has two files, the app_test.dart and the app.dart file. And both of them, as we know already, they're gonna contain a main method, and we're gonna just have to complete or fill the gaps. So for the app method, what do we need to do? Well, we're gonna import the driver extension from the Flutter driver package. And then we're gonna have a reference to our main method of the Android Summit 2020 app. And we're gonna actually, in this case, give it an alias so it doesn't override our main method that we have already in this file. And then inside the main method, we're gonna call enable Flutter driver extension and just execute our app.main. We run the application. On the second file, on the app_test, very simple. We're gonna get a reference to the Flutter driver. And what we're gonna do is to actually connect our Flutter driver before we execute any test. And after we execute all our tests, we're gonna close that instance so there's no memory leaks. And how do we write this test? Very simple. We're just gonna create a new group and we're gonna test that the application, like the project, completes the game after 3 questions. In this case, we're not mocking anything, we're just testing the application as it is. That's why it's an integration test. We test everything. So in this case, the driver, we can call like driver wait for and find text in the screen. And then we can tell the driver to tap certain buttons. In this case, we're tapping the yes button. We're gonna wait for the second question and we're gonna tap a new button. And then we're gonna wait for the third question. We're gonna tap a new button, in this case, no. And finally, we're gonna get our score and we're gonna assert, or like in this case, wait for the fact that we can show the final score. So very simple, we just have to find the elements that we wanna see or tap on the screen and interact with them. If we want to run this test, what we do is to run this command on our terminal. Flutter driver, the target flag is gonna point to our app file, to our target file, and the driver flag is gonna point to our scripted test. So let's run this on the terminal. Let's see how it executes. I fast forwarded the video a little bit, so this is Gradle. It's not the fastest, we know that. But like, this is the magic of not doing this live. I can fake it a little bit. But then once we have that, as we can see, those interactions happen quite fast. Let's see that again, right? We pretty much spend more time building the project than actually running our test. But what we did is to answer the first question, answer the second question, answer the third question, see the success message, the game completed message, and we're done. That was fast. So far then, what do we have? We've run our unit test, we've done our widget test, and finally we've completed our integration test. So the question is, with all these tests that we have available, what can we do with them? Well, I think that the best thing that we can do with them is to run them on some type of continuous integration tool, right? So for the Flutter community, there's no question about it. Our favorite tool is CodeMagic. It's completely like fully dedicated for Flutter. So if you have the chance, run your tests, your automations on CodeMagic. You can also do the same thing for GitHub Actions, right? As long as you get access to a Flutter image, you can run the same commands that we had on this tutorial on GitHub Actions. The key here is that automation for the win, right? Like if you can run this on an automated way, it's always going to be a success. I have a little surprise for you. I apologize that we went kind of fast through this test. We have the time that we have in this talk, but actually today at the same time, I hope that my new lesson, my new class on testing for Flutter on caster.io is going to be released. So if you're interested in learning more and getting more details about testing, go to caster.io, register, get an account, and check out my testing lesson. I'm sure that you're going to love it if you love testing on Flutter. And with that said, like we've covered all the content that I have. So if you want to know a little bit more about me, my name is Jorge Coca. I work at Very Good Ventures. Very Good Ventures is a only Flutter consulting company. We were the first in Flutter with the Hamilton app, and we want to think that we're doing a pretty good job with Flutter. So if you have any questions, give us a call or contact us through the website. I'm also a GDE for Flutter. I wouldn't call myself an expert, but like I kind of enjoy talking, so that's nice. You can find me on Twitter under jcoca_ramos. And finally, if you want to access this project, you can find it on GitHub under my account, Jorge Coca, and then the project is called Android Summit 20. That said, I really, really apologize for not being live. I miss you all, and thank you so much. See you next time.